Welcome! Let's solve a capacitor network problem step by step. We are asked to find the potential difference between points A and B, given an EMF of 110 volts and a capacitance ratio C2 over C, 1 equals 2. First, let's draw the circuit. We have a source on the left, two capacitors labeled C1 in series across the top, and two capacitors labeled C2 connected from the top line down to the bottom line. The rightmost top node is point A, and the bottom right node is point B. Now, we solve using node voltages. Let the bottom wire be 0 volts. Let V1 be the voltage at the middle node, and VA be the voltage at point A. Because these nodes are isolated conductors, the net charge at each node is 0. At node VA, the sum of charges must be 0. The charge on the C1 connected to V1 is C1 times VA minus V1. And the charge on the C2 to ground is C2 times VA. Setting the sum to 0 gives our first equation. At node V1, we have three capacitors connected. The charge on the left C1 is C1 times V1 minus 110. The charge on the right C1 is C1 times V1 minus VA. And the charge on C2 is C2 times V1. Adding them and setting the sum to 0 gives the second equation. Now we use the given ratio. C2 equals 2 times C1. Substitute C2 equals 2C1 into both equations, and simplify. From the first equation, V1 equals 3VA, substitute into the second equation. 4 times 3VA minus VA equals 110. That gives 11VA equals 110. So VA equals 10 volts. Finally, point B is on the bottom wire, which is 0 volts. So the potential difference, VA minus VB, is simply 10 volts.